How's it going, everybody? In this video, I'm going to be talking about radical expressions. And radical expressions are like square roots, cube roots, fourth roots, all these roots, things like that. As you can see, we're going to be simplifying the square root of 32 here. So this is stuff that we had to be doing in the quadratic formula, stuff like that. Bananas, apple pies, fruit pies, fritters. So a couple ways you can do it. If you want, I feel like a crazy person talking to nobody because you're not supposed to be here. It's like the square root of 2 times square root of 16, because that's what 32 is. We know the square root of 16 is 4, so this is like 4 root 2. That would be our solution. Another way of doing this is if you take 32 and you break it down to the prime factorization, so what that means, I'm doing 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So I can see I have 1, 2, 3, 4, 5 2's. So this is the same thing as the square root of 2 to the 5th. I will tell you that the square root of something is that thing to the 1/2 power. So if I rewrite this, this is going to be super useful later on. This is 2 to the 5th to the 1/2 power, which would mean I have 2 to the 5/2 power because I multiply those things. Now 5 divided by 2 is 2.5. So what that means is since I can break this up as 2 to the 4th times 2 to the 1/2 to the 4 over 2. 4 divided by 2 is 2, so 2 squared times 2 to the 1/2, which is 4 times the square root of 2, because I know 2 to the 1/2 is the same thing as that thing to the square root. Words. Okay, so that's essentially what we're going to be doing, except we're not always going to have square roots. This little 3 on the outside, tiny 3 on the outside, that means doing the cube root. It's okay, don't worry, it's fine. It'll be okay. So what this means we can do is we have 2 times 8, which is 2 times 4, which is 2 times 2. So this same thing is taking the cube root of 2 to the 4th power. So I have 1, 2, 3, 4 2's. So I can break this up because 4 divided by 3 is 1 1/3. So what that means is I have 1 2 on the outside and another 2 left on the inside. So this is 2 times the cube root of 2. Same idea, except now I have a 5th root. It's still okay. Don't worry about me. They'll institutionalize me one day. That way I can run against the walls and not hurt myself anymore. So here we have 1, 2, 3, 4, 5, 6 2's. So what this means, we have the 5th root of 2 to the 6th. So once again, if I take out 2 to the 5th, I can put a 2 on the outside. 6 divided by 5 has a remainder of 1, so I have 2 times the 5th root of 2 still. That will be our solution. Capital. Cube root of 125. This is 5 times 25 times 5 times 5. So what this means, I have 1, 2, 3 5's. So this is the same thing as the cube root of 5 to the 3rd. Well, that divides out evenly, so this is just, because since 3 divided by 3 is 1, I just have 5. So 5 to the 3rd is 125. Oh yeah! All right, 24, m to the 3rd. So now we have an m involved, but we can still break up the number like we're used to doing. So there's 2 times 12, which is 2 times 6, which is 2 times 3. So now I have a 3 left. So the same thing as square root of 2 to the 3rd times 3 times m to the 3rd. So this 2 to the 3rd, I can bring out a 2 and leave a 2 on the inside because 3 divided by 2, since it's a square root, it has a remainder of 1, and I can bring out 1 full on the outside. 3 I have to leave on the inside. M to the 3rd, 3 divided by 2 again, is 1 with a remainder of 1. So now last thing I'm going to do is just multiply that 2 times 3. So this will all be 2m times the square root of 6m. Capital. All right, looking at this one, cube root. 16, so 16 is 2 times 8. 8 I know is 2 to the 3rd, so this is 2 to the 4th. So the cube root of -2 to the 4th, a to the 4th, b to the 9th. So if I divide these things out, I can bring out a -2. I have a 2 stuck on the inside. A to the 4th, so I can bring out an a, and I have an a stuck on the inside since 4 divided by 3 is 1 with a remainder of 1. B to the 9th, if I divide that by 3, that is just b to the 3rd on the outside, so I don't have any more b's on the inside. So if you want to rewrite this, make this look a little bit prettier, it's -2ab to the 3rd with the cube root of 2a still left. Woo! Alright, simplify this guy. 128 can break down into 2 and 64, which can break down to 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and yes. 1, 2, 3, 4, 5, 6, 7 2's. So we have the 4th root of 2 to the 7th n to the 5th. Now if I divide both these exponents by 4, so by 4 and by 4, I can bring out 1, 2. Since 7 over 4 is 1 and 1/3, so 1, and I would still have the remainder of 3 left on the inside. 5 over 4 is 1 and 1/4, so I have 1 on the outside and 1 on the inside. So I can rewrite this, make it look a little bit prettier. 2n, the 4th root of 8n. That's what I'm going to be looking for. All right. Un momento.
Now with adding and simplifying, we have to make sure that it's the square root or whatever root of the same number.
You should be when you have videos like that.
I am.
What?
Now you're in
it. All right, so what I said is if you have the square root, we have to have the square root of the same number in order to add and subtract. Whatever these things, make sure it's kind of like the same variable. So with the square roots of 3, -3 and -3 together make -6. Root 3, I'll keep the same square root. And minus root 8, well, maybe root 8 has a root of 3. So if I simplify that, that's 2 times 4, which is 2 times 2. So I can pull out a 2, so it's not. But I can rewrite this as 2 square root 2. So since these do not have the same square root, there's nothing more that I can do. Make sure they have the same square root or whatever root in order to combine them. Hockey day! All right, so now we're dealing with cube roots. But notice, these all have cube root of 80, cube root 80, cube root 80. So I can just go ahead and combine those things. So I have 2 minus 1 is 1, plus 3 is 4. So I have 4 cube root of 80 minus 2 cube root 135. All right, so now let's break those things up, see if those will combine. Cube root of 80 is 8 times 10. That's a perfect cube. Cube root of 135, let's see, we'll have 345. That's 15 times something. 15 times 9, so it must be 27. 27 times 5. This is also a perfect cube. So we have, all right, so this is 2 to the 3rd, this is 3 to the 3rd. If I'm pulling out a 3, I'm going to go ahead and multiply it by that 2, and here I'll pull out a 2, so I'll multiply it by the 4, so I have 8 cube root of 10 minus 6 cube root of 5. That is how I will want to see your answer. All right, moving forward. Forward we go. Yes, into the great unknown. 48. So we have 2 and 24, 2 and 12, 2 and 6, 2 and 2. 3, 6 is 2 times 3. So pull out a 2, so I'll have 2, 4th root of 3. 243, let's see, it's 3 and 81, which is 3 and 27, which is 3 and 9, which is 3 and 3. So I will pull out a 3. 80 again. So we already did this. We know 80 is 2 root 10. Oh, but that was the 3rd root. My bad.
My B.O. It's super stinky.
So we have 2 and 40, 2 and 20, 2 and 10, 2 and 5. So I can pull out the 2. All right, so now I had 2 fourth root of 3. I have minus 12 because we already had a 4 in front, so I'll multiply by that. Fourth root of 3, and then I already have a 2 in front, so I'll multiply again, so plus 4 times the fourth root of 5. The only things I can combine are those two right there, so I'll combine those. So 2 and negative 12 is negative 10. Fourth root of 3 plus 4 times the fourth root of 5.
Oh, yeah. Oh.
All right, so now multiplying. Multiplying is super simple. So all we're going to do is multiply the insides together. So this will be like the square root of 32, which square root of 32 we did on the very first problem. Oh, look at that. Look at that. We can use the answer again. So we know it should be 4 root 2. What was that?
That was a banana. It was a monkey eating banana.
All right, so multiplying again. Don't worry about the root. Just make sure they're the same root. So here we have some outsides. So we're just going to multiply the outsides as well. So we'd have 8 times the cube root of 9 times 15 is 150 minus 15, so 135. Cube root of 135 we did already, but we'll do it again. So this is 27 times 5. So I can pull out a 3 because 27 is perfect cube. It is 3 to the third. So I have 24 times the cube root of 5. Tap it day. All right, next and last thing we're going to look at is dividing these things. So with division, I want you to know and remember from Algebra 1, it's okay if you don't, but we will, 24x to the third, y to the sixth. If I have the same root divided by the same root, so here I have square root of something divided by square root of something, it's the same thing as that thing divided by each other inside the same square root. So knowing that, it makes it a lot easier to simplify these things. So then 24 divided by 12, divided by 2 is 12. X cubed divided by an x would give us x to the second. Y to the sixth minus one more would give us y to the fifth. So then I can simplify this. So I know 12 is the square root of 4 times square root of 3. So this is 2 with a 3 on the inside. X squared, I can take out both of those. I can take out 2 y's, and there is still 1 left on the inside. So that would be our solution for that. All right, looking at another. That says A. So we have the cube root of 54, a to the 8th, y to the 17th, divided by the cube root of 2a to the 2nd, y to the 7th. So again, let's rewrite this thing under the same cube root, just to make it easier to divide these things. So we have 54, a to the 8th, y to the 17th, 2a to the 2nd, y to the 7th. So if I divide these as I see, 54 divided by 2 is 27. A to the 8th divided by a to the 2nd is a to the 6th. 17 minus 7 is y to the 10th. It's still under the cube root. So now I need to take the cube root of all these things. So 27, 3, 9, and 3, 3. That's a 3. So I can take out the whole thing. So I have a 3 on the outside with nothing left on the inside. 6, if I divide that by 3, it divides evenly, it is 2. So with no remainder, nothing goes on the inside. 10 divided by 3 is 3 1/3, so I can take out 3, and I still have 1 y left on the inside because it was a remainder of 1. All right, and that would be what I'm looking for. Hopefully this video is helpful for you guys. As always, please come ask questions. I'm here for you guys. Love you guys. Bye.